Hello, Classoffour here. So today we're going to be looking at this physics problem, which is actually quite interesting. In 1997, a high-speed car of mass 1.1 times 10 to the 4th kilograms achieved the world land speed record. Cool. The car accelerated uniformly, and this is what's key here in the question, uniformly, in two stages as shown in the table. The car started from rest. Okay, so we're given this data here, and here are our questions. So the first question is, calculate the average acceleration of the car in stage 1. Let's go do this now. So we know that the formula for average acceleration is the change in velocity over the change in time. Now this translates to v2 minus v1, which means the final velocity in that stage minus the initial velocity in that stage over t2 minus t1. t2 is the time, the end time of that stage, and t1 is literally 0. It's going to be the beginning of that stage. And since the stage we're talking about is stage 1, you can see here, the first time is 0. So let's substitute our values. So we have 44 minus 0, and we know that v1 is 0 because the question said that the car started from rest, which means that it starts at the velocity of 0. So 4 minus 0. Good. So this simplifies to 11. And let's not forget about our units, because that is a common mistake that many people make. So let's make some sense of this. So we have our magnitude, and okay, so we need our units. So what are we dividing, and what unit are we dividing by what? Well, we're dividing meters per second by seconds, because meters per second is velocity, and we're dividing velocity by time. So meters per second over a second, and this is equal to meters per second, which is meters over seconds squared. And that turns out that that is also acceleration. So that makes sense. That confirms the answer itself, that the average acceleration is going to be 11 meters per second squared. Awesome. Let's do question B now. So, average net force required to accelerate the car in stage 2. Okay, so this is a more tricky question than the first one, but again, it's still very simple if you understand the concepts. So in this question, we will be using Newton's law, which dictates F equals ma. The force is equal to the mass times the acceleration. And we're doing this because we're asked to calculate the net force to accelerate the car in stage 2. So we're trying to find this variable, and we have to figure out this and this variable to calculate force. So what's our mass? Well, as the question stated, our mass is 1.1 times 10 to the 4, so that's 1.1 times 10 to the 4 kilograms. Acceleration, well, we're going to do exactly what we did in part A, which is delta V over delta T, and this is V2 minus V1 over T2 minus T1. This is, well, our final velocity is 280 minus 44. Now, why is it minus 44? Well, 44 comes from the information that is given from here, 44, because at stage 2 the initial velocity is 44. So moving on, our final time, which is the end time, which is given right here, is 12 seconds, and the initial time for stage 2 is 4 seconds. So it will be 12 minus 4. Now let's simplify this. So this is 236 over 8, and this is some simple calculator work. 236 divided by 8. This gives you, we'll run it off, we'll give it 30 meters per second squared. Don't forget your units. So now that we have meters per second squared, we have our mass, we have our acceleration, average acceleration that is. So now we can calculate the force. So force net is equal to 1.1 times 10 to the 4 multiplied by 30, and our F net is gonna equal, let's plug this in the calculator, 1.1 times 10 to the power of 4 times 30, and this gives us 33,000 newtons, because we know that force, the unit of force, is in newtons. So that's our answer. Good. So that is the minimum force required to accelerate the car in stage 2. Now, if you wanted to simplify this a bit further, you could simplify this to 33 kilonewtons, because a kilo is 1,000, which states as 33,000 newtons. Alright. C. And whoops, let me just erase this. Okay. Alright. What is C asking us? Well, C is asking the total distance traveled by the car in 12 seconds. Okay, so this is even a more tricky question, but again, it's just simple understanding. And in this question, we will need one of the great 5 kinematics equations, which everybody should memorize, or at least understand. I mean, they are very useful in the physics world. So, and we know we can use these kinematics equations because acceleration is uniform, and that's when we can use these kinematic equations. So, total distance traveled by the car in 12 seconds. So, the main way or method you want to approach this is find out how much distance did you travel in stage 1, how much distance did you travel in stage 2, and then add those two distances to find how much total distance the car traveled in 12 seconds. So let's calculate the distance traveled in stage 1. And the kinematics equation I'm going to use is distance is equal to velocity, initial velocity, plus final velocity over 2 times the time. So let's look here. Okay, so this is for stage 1. So we have v1 plus v2 over 2 times time. So we have to find distance, and velocity 1 is obviously 0. Velocity 2 is 44 over 2 times the time, which is 4. Therefore, using math, we'll just simplify this. So this is 22 times 4, and this equals 88 meters. So that means in stage 1, the car traveled a total distance of 88 meters. So we have 88 meters here. Now let's do the exact same thing for stage 2. Okay, stage 2. So we know distance is equal to velocity 1 plus velocity 2 over 2 times the time. So what is our initial velocity? Well, we know it's 44. final velocity. It's 280. And this is all just information taken from this data right here. Amazing how much you can do with just 4 pieces of data. So 280, yep. And then our over 2 goes there, times the time, which is 8. Okay, so let's add these two and simplify mathematically. Sorry, my throat. 324 over 2 times 8. And this, I will just use the calculator. So 324 divided by 2, and then that is 162 times 8, and then using the calculator again because my mind is not strong enough to do this. I don't know whose is. If you can, thumbs up. 96 meters. There you go. So now we know in stage 2 the car traveled a total distance of 1,296 meters from the start of stage 2 to the finish of stage 2. Excellent. Now, let's add these two numbers together to find the total distance that the car has traveled from 0 seconds to 12 seconds. So 1296 plus 88 equal to 1,384 meters. And that is the final answer for C. And as you can see, this stuff is pretty simple. The hardest part to these type of questions is understanding what the question is asking and what formula to use. After you know that, it's simply just plugging in the variables and also using very, very simple math to solve for them. And there you go. If you have any questions regarding this question, feel free to leave a comment. If you have any questions on what I did here, if you don't know what's going on or want further explanation, feel free to ask questions and leave a comment. Thank you.